FreeCAD is a fully open source computer-aided design program. Its open source nature means, for one, the application costs nothing to use, it's free to download. However, what open source really means is that anyone can view the source code and modify the software to their liking or for perhaps more specialized use cases. The flip side of this is that because it's free, its development and maintenance rely on the authors committing their unpaid spare time to work on the application. Hence, FreeCAD is perhaps a bit less polished than something commercial like Fusion 360, Onshape, or SolidWorks. Many find the software to be quite daunting at first. Nonetheless, it's a powerful application that, if wielded correctly, can allow professionals and makers alike to create and do things that might be tricky in alternative CAD programs. Throughout basically all of my 3D printing projects, I have used FreeCAD as my sole piece of design software. Other options may have had a lower skill floor and I might have been able to afford them, but I don't like being tied to a license. Blender is another open source option, but it is much better suited for organic shapes and making things like digital art and video game assets. FreeCAD is the complete opposite. It primarily excels in the creation of practical, functional parts, and more organic geometries can be hard to work with. With that said, I wanted to zoom in a bit, teach you guys some of the basics and how to get started. By the end of this video, you should have a firm understanding of the foundations. Welcome to Doing It Ourselves. Today, we demystify FreeCAD. After downloading the latest version of FreeCAD and opening it up, you will be greeted with the welcome page. From here, you can create new files, open recent existing ones, and view the examples provided. Towards the top of the page, you should see a toolbar with a list of icons. On the welcome page, these are grayed out. To start a new project, either navigate to the File button and select New from the drop-down box, or simply use the shortcut Ctrl-N. This opens a new FreeCAD file. The easiest way to name this file is simply to save it using Ctrl-S and to name the file upon saving. Names of things can also be changed from the inspector on the bottom left of the GUI. Speaking of the GUI, all tools in FreeCAD are grouped into spaces called workbenches. There are plenty to choose from, and they all have their use cases. You could even download more third-party workbenches, and an example of this is the gear workbench, which makes it very easy to create gears. However, 90% of the time, you're going to be either using the Sketcher or Part Design workbenches. You might wonder why my UI looks a bit different to yours, but that's just the theme I've set it to. My application is the same one you are using if you're following along with this video. To actually get started making something in FreeCAD, the first thing we need to do is create a body and make it active. Think of bodies like containers for all the parameters of an object. We make the body active because in FreeCAD you can actually have multiple bodies within the same file, and so by making the body active, you are choosing which object within that file you want to work on, without affecting the other bodies. Now, the thing that catches people out with FreeCAD when they first start is how an object is built within a body. Unlike some other pieces of software, there is a hierarchy of iteration. Every iteration of an object is built upon the last, and also, most features of an object are derived from sketches. This sounds like a bunch of gibberish, but as we go along, you'll understand what I mean. Let's actually move on to sketches now. The vast majority of FreeCAD projects start with sketches, which will map out the geometry of the object you want to extrude, pocket, etc. To create a sketch, you can either navigate to the Sketcher workbench and click Create Sketch, or you can find the same button located within the Part Design workbench. Just make sure that when you create a sketch, the body you are creating it within is active. When you create your first sketch in a project, you'll be asked which axis you want to base it off of. I mostly use the XY plane, but it doesn't matter too much for basic things. After you've selected an axis, your view will change from the 3D view you were greeted with at the start to a 2D coordinate plane. Additionally, you'll be moved automatically into the Sketcher Workbench if not already. In the Sketcher Workbench, you have two different types of tools at your disposal. You have your shape tools, which are used to actually draw your geometry, and you also have your constraint tools. The purpose of constraints is to limit what's called degrees of freedom, and there are multiple reasons why you may want to limit those. For example, if you try to draw a shape with lines, but one end of a line doesn't connect with another, what we call coincidence, then the shape you have created will be impossible to extrude, or in FreeCAD, pad, because the shape is incomplete. All points must connect. They must be coincident in order to be used. Constraints are also used for precise measurement and to clearly define tolerances. With that out of the way, let's create a sketch. To start, let's create a simple cube. So we've created a sketch, and now what we need to do is create our shape in this 2D sketcher plane. So firstly, I'm going to create a simple square by clicking on the Create Rectangle icon. I'm going to click on a point within our sketching space, and I'm going to drag the cursor to define a rough shape and size of the rectangle, followed by clicking once again to create the shape. Now, we can click and drag on the lines and points of the shape to adjust its size, etc. But that's a very inaccurate way of doing things. We are now going to use constraints to define the measurements of the shape. In this instance, we need two, one constraint for length and one for height, and these can be found within the toolbar towards the right of the shape tools. You click on the constraint you want to apply, and then click on the line or point you wish to apply it to. This should prompt you with a small window where you type in the value of your desired measurement. The standard is millimeters, but other units are also available. Once you have defined your measurement and confirmed it by selecting OK, the shape should automatically transform according to your input measurements, and you'll get a red constraint line denoting said measurement, which you can move out of the way by clicking and dragging it. Now, what constraints also allow you to do is define a specific distance from a point in 2D space. So, if I wanted my square to be perfectly centered, for example, I would constrain the length and height, but I would also add the same constraints relative to the central point. In this case, half length and height from the center. If we exit out of the sketch, navigate to the Part Design Workbench and select Pad and hit Enter or press OK, we get a simple cube. But what if we want to add a feature to this cube? What if we wanted to add a hole in the center? Well, there's a few different ways of doing this. We could, for example, select a face of the cube and create another sketch on that face, and on that second sketch, draw a circle, and then do something called a pocket, which is basically the opposite of a pad. It subtracts instead of adds to the object. There is also a dedicated hole tool for creating holes, and you can use this feature to easily make things like threaded holes. This is a lot easier to do in this version of FreeCAD. In older versions, creating a thread was a very janky process, let's say. So I'm really pleased that in 1.0, they've integrated threading into the hole tool. However, yet another thing you can do, if all you want is a simple hole, is you can simply go back and edit the initial sketch and add a circle to the middle of the sketch, and FreeCAD will automatically make the 3D edit for you. However, I would be careful doing this on very complex projects, as it could mess with your entire project if you edit something that a later feature depends on, because of the way FreeCAD works. Speaking of circles, they also have their own applicable constraints. You can constrain for things like radius, position, diameter, etc. And that can be very useful. The Sketcher has other shapes like semicircles, which I don't really use that often. They have their use cases. I do sometimes make use of the bestigons, and their constraints kind of work somewhat similarly to circles in some ways. You can also make your own custom shapes using lines, but I don't really like doing that so much. I encourage you all to, at the end of the day, just play around and get a feel for all of this, because your experience is going to be way more valuable than what I'm telling you here. I really recommend that you properly familiarise yourself with sketches in FreeCAD, because you're going to be spending a lot of time in this workbench. Now that we've covered the basics of the sketcher, we're now going to move on to perhaps the other workspace you're going to be interacting with for the vast majority of the time you spend in FreeCAD, and that is the part design workbench, and we've already touched upon it a little. But let's go a bit deeper. The part design workbench is where most of the magic happens. It's what turns your sketches into 3D objects, and it allows you to further refine existing objects without creating another sketch. As we discussed earlier, the pad tool is what you use to extrude sketches. However, both pads and pockets can take place on already existing geometry. Let's return to our cube with a hole in it. From the sketch, if I click pad, you will see that the sketch is extruded. But what I can also do is select one of the faces of the cube and click pad again, and it will extrude in the direction of that face, as you see here. This also works with pockets. So if I select a face and click pocket, it will make a cut into the object, while retaining the shape of the face as it cuts. Now you can actually have multiple faces on the same plane. If I undo the pocket, you can see that there is a line between where I have padded and the original object. These are two separate faces. This might seem annoying at first, but once you get the hang of things, you can actually exploit this to your advantage. Okay, so the next thing is how to do a revolve in FreeCAD. If we start from scratch and create a sketch, let's just create a random shape, place it a bit off center, don't need to constrain it so much just for this demo. If we then take the sketch and revolve it by first clicking on the sketch and pressing revolve, FreeCAD will generate a 3D shape based on a 360-degree rotation of that sketch. You can play around with these settings, but if we click OK, we now have our revolved object. Obviously, you can fine-tune the sketch, constrain it, etc., but the process is the same. Fillets and chamfers can be used for many reasons: to improve fit, as a feature themselves, such as in the case of my centrifuge, or to simply improve the aesthetic of a design. FreeCAD has both a fillet and chamfer tool, and using them is relatively straightforward. So I've created another cube here, and what I'm going to do now is select a line on the edge of the cube and click fillet. Now, as with other tools like pad, pocket, etc., you can adjust this to your liking. You can increase the size of your fillet, or you can make it really small. You can also manually type the value you want. This creates a fillet. The process is very similar for chamfers. However, with chamfers, you have a few more options. You can adjust things like the angle of the chamfer, where it starts and ends, etc. The important thing to remember is that fillets and chamfers are features of an object. What this means is that it's very risky to create, say, a fillet and then go back and edit something further up the hierarchy. So, unless you absolutely have to, I recommend leaving your fillets and chamfers until the very end of the design process, so you minimize the risk of breaking the model. Now that you have a finished model, you're going to want to export it for 3D printing, CAM, CNC machining, etc. To do this in FreeCAD, either select the body you want to export or double click on the model. Then either go to File and click Export, or use the shortcut Ctrl-E. Next, name your model and choose your exported file format. STL is commonly used in 3D printing slices, so that's what I use most of the time. And now if we open up Cura, we can find and open our STL file and go from there. The process is similar for most slices. Well, there's a basic rundown of how to get started making things for your projects in FreeCAD. In the future, I'm going to go deeper and talk about designing for 3D printing, and go into more depth on some specific workbenches, such as the gear workbench, and how to use it to create gears and implement them in your project. Anyway, thank you all for watching, take care, and I will see you in the next video.